Every diagram of the solar system you have ever seen tells you the same comforting lie. The planets end at Neptune, and beyond it there is nothing but empty space. But here is what they left out. Just past that last blue world begins a frozen expanse, so wide that the entire parade of planets could fit inside a fraction of it, filled with hundreds of millions of icy worlds we did not even confirm were real until 1992. Out there, 4 billion miles away, the air you breathe lies frozen on the ground as hard as stone, water builds mountains, and a tiny world 5 times smaller than Pluto is somehow exhaling an atmosphere it has no right to hold. The map you grew up with did not just leave out a few objects. It left out most of the solar system. Get comfortable and let your shoulders drop. Hit subscribe if you are new here, because by the end of this, the blank space at the edge of that childhood diagram is going to feel very different. Now, let's slowly ease into this. Part 1. The room you never noticed. Right now, while you are lying here, there is a place roughly 4 billion miles from where you are resting, where the temperature holds steady at around -230 degrees Celsius. And the sunlight is so faint that it would feel less like daylight and more like a single bright star burning in an otherwise black sky. You cannot see this place. Almost no one alive has ever truly looked at it, because for most of human history, we did not even believe it was there. And yet it is one of the largest, most populated regions of the solar system, far bigger than the familiar zone of planets. I want you to picture the solar system the way it was probably taught to you. There is the sun in the center, warm and golden. Then come the planets in their neat procession: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and finally Neptune out at the cold blue edge. And then, in most of those diagrams, the picture simply stops. The planets end at Neptune, and beyond Neptune, there is a kind of blank space, a margin at the edge of the page where nothing is drawn, as if the solar system has a wall at its far border, and there is nothing past it but empty night. That picture is wrong. It is not slightly wrong. It is wrong in the way a map would be wrong if it showed only the entrance hall of an enormous house and left every other room blank. Because just past the orbit of Neptune, the solar system does not end. It opens. It widens into an immense, frozen, three-dimensional expanse filled with hundreds of millions of icy worlds. A region so large that the entire parade of planets you learned in school could fit inside a fraction of its width. This is the Kuiper Belt. And the truth of what it is actually made of is far stranger and in its own quiet way far more unsettling than anything that simplified diagram could ever suggest. Think of the everyday solar system, the part with the planets and the warmth and the light, as a single room, a small, well-lit, comfortable room, the kind you would feel safe falling asleep in. For thousands of years, human beings believed that this room was the whole house. We mapped its corners carefully. We named everything in it. We grew so familiar with it that it stopped feeling enormous and started feeling almost cozy, a tidy little arrangement of worlds circling a fire. But the room was never the whole house. Beyond its far wall, where the diagrams went blank, there was always an entire wing of rooms stretching off into the dark, room after room after room, colder and emptier the farther you go, and we simply never noticed them. The Kuiper Belt is the first of those rooms, and tonight we are going to walk into it slowly and look around and find out what it is really made of. The name comes from an astronomer named Gerard Kuiper, who in the year 1951 suggested that a disk of leftover icy material might once have existed beyond Neptune. There is a small irony buried in that, which we will come back to later, because Kuiper actually thought this material had long since been scattered away and would no longer be there to find. An Irish astronomer named Kenneth Edgeworth had floated a similar idea a few years earlier, imagining a reservoir of small frozen bodies waiting in the outer dark, which is why you will sometimes hear the region called the Kuiper Belt. But for 4 full decades after these ideas were first written down, the belt remained nothing more than a suggestion on paper. No one had ever seen a single object out there. The only known world beyond Neptune was Pluto, discovered back in 1930, and Pluto was treated as a lonely oddity, a single, small misfit drifting at the edge, rather than as the first member of an immense and hidden population. What changed everything was a faint point of light captured on the night of August 30th, 1992. 2 astronomers, Dave Jewett and Jane Liu, had spent 5 long years searching the sky from the top of a mountain in Hawaii, night after night, finding nothing at all. 5 years of patience and disappointment, and then, finally, they found it, a dim, slow-moving speck at a distance of roughly 44 astronomical units from the Sunday. They gave it the unromantic designation of 1992 QB1. It was the first confirmed object of the Kuiper Belt ever discovered beyond Pluto and its moon, and in that single faint smudge of light, the blank margin at the edge of the map suddenly filled with possibility. The wall at the edge of the house was not a wall at all. It was a doorway, and on the other side of it was everything we had failed to imagine. In the 3 decades since that discovery, astronomers have directly catalogued more than 3,000 individual Kuiper Belt objects. But the catalogue is only the part we have managed to see so far. The models, built from everything we know about how the region behaves, suggest that the true population is staggering. More than 100,000 objects, larger than 100 kilometers across. And if you count the smaller bodies, the ones just a kilometer or so in size, the number climbs into the hundreds of millions. Hundreds of millions of frozen worlds, almost none of which have names, almost none of which any human eye has ever resolved. All of them drifting silently in a region we did not even confirm existed until 1992. That is the scale of what we are dealing with. And the word in the title, the word terrifying, is not there to promise you a monster or some incoming object hurtling toward Earth. There is no such thing waiting in this story, and I would not keep you company through the night with a cheap scare. The fear in the Kuiper Belt is something quieter and far harder to shake. It is the fear of scale. It is the fear of cold. It is the fear of emptiness so complete that it dissolves the comfortable sense that we understand the place we live. It is the slow realization, building fact by fact, that the orderly solar system you were taught is only the small, warm, well-lit core of something vastly larger, vastly colder, and vastly stranger than anyone ever showed you. By the time we are finished, the blank space at the edge of that childhood diagram is going to feel very different. It is worth pausing on how recent all of this knowledge really is, because it changes how you should feel about that childhood diagram. The people who drew the solar system for your textbooks were not being careless. For almost the entire history of astronomy, there was simply nothing to draw out there. Galileo never knew the Kuiper Belt existed. Newton never knew. The astronomers who mapped the orbits of the planets with extraordinary precision, who predicted eclipses centuries in advance, who discovered Neptune itself through the tug of its gravity on Uranus, none of them had any idea that beyond Neptune lay the most populous region of the entire system. The confirmation came in 1992, which means that there are people alive today, perhaps including you, who are older than humanity's certain knowledge that the Kuiper Belt is real. For most of the time, human beings have been looking up and wondering. The largest structured population of worlds in our own solar system was completely invisible to us, hidden in plain sight, just past the last planet, waiting in the dark to be noticed. And the reason it stayed hidden so long is itself a measure of how strange and remote this place is. The objects of the Kuiper Belt are small, and they are unimaginably far away, and they are dark, reflecting only the feeble light of a distant sun back across billions of miles. A typical Kuiper Belt object, a body perhaps 100 kilometers across, appears from Earth roughly 10 million times fainter than the dimmest star your unaided eye can see on the clearest night. 10 million times fainter than the faintest thing you can perceive. That is why it took telescopes on mountaintops and years of patient searching to find even one. These are not bright, obvious worlds. They are faint smudges at the very limit of detection, and there are hundreds of millions of them, and every single one is a frozen world in its own right, with its own surface and its own history and its own slow story unfolding in the dark, almost all of it entirely unknown to us. So settle in and let your shoulders drop, and let the warmth of your room hold you while we drift outward, far past the last planet, into the frozen wing of the house that no one ever pointed out. Because the question we are going to answer tonight is deceptively simple. What is the Kuiper Belt really made of? The answer is going to take us through frozen oceans and nitrogen glaciers, through a tiny world that touched another in near silence 4.5 billion years ago, through dust that refuses to end where it should, and through a single small object that is breathing out an atmosphere it has no right to possess. And every step of the way, the room we live in is going to feel a little smaller, and the dark beyond it a little larger. Let us begin where the modern story of this place truly opened, with a single spacecraft, no heavier than a piano, crossing 3 billion miles of darkness to reach a world we thought we already understood. Part 2. A spacecraft, no heavier than a piano. In the year 2006, a small machine left the Earth on top of a rocket called an Atlas V, and it left in a hurry. Most spacecraft ease away from our planet at a measured pace, but this one, named New Horizons, was flung outward faster than anything humans had ever launched. To give you a sense of just how fast, consider that it crossed the orbit of the Moon, a journey that took the Apollo astronauts 3 days, in only about 9 hours. 9 hours to reach the Moon's distance. It passed the orbit of Mars in a matter of months, and it was hurrying for a reason, because its destination was so far away that even at this tremendous speed, the trip would take the better part of a decade. To understand why a mission to Pluto mattered enough to attempt, you have to understand how long Pluto had taunted us. For 76 years, from its discovery in 1930 until New Horizons launched in 2006, Pluto sat at the edge of the solar system as the one major world we had never visited, never photographed clearly, never truly seen. Every other planet had been visited by a spacecraft, but Pluto remained out of reach, too small and too distant, a stubborn blank in the family portrait of the solar system. New Horizons was, in a real sense, the mission to finish the map, to fill in the last unknown major world, to complete a reconnaissance of the classical solar system that had begun decades earlier. The target was Pluto, that lonely misfit world at the edge of the planetary zone. And it is worth pausing on how little we actually knew about Pluto before this mission arrived. For 3/4 of a century after its discovery, Pluto was little more than a smudge. Even the most powerful telescopes on Earth, and the Hubble Space Telescope in orbit above the atmosphere, could resolve it as nothing more than a blurry blob of a few pixels, a faint patch of light with vague suggestions of bright and dark regions. We did not know what its surface looked like. We did not know whether it had mountains or plains or craters. We had guesses, and the guesses leaned toward the obvious assumption. Pluto was small, and it was unimaginably cold, and small cold worlds at the edge of the solar system were expected to be dead. Frozen solid all the way through, a cratered, inert ball of ice and rock that had not changed in billions of years. New Horizons used a clever trick to gain speed on its way out. It aimed itself at Jupiter, arriving there only about 13 months after launch, and used the giant planet's immense gravity as a slingshot stealing a little of Jupiter's orbital energy to fling itself onward toward the outer solar system even faster than before. This is a technique called a gravity assist, and it is one of the most elegant ideas in all of spaceflight, a way of accelerating without burning a single drop of extra fuel, simply by falling past something enormous at exactly the right angle. With that boost, New Horizons settled into the long, quiet cruise that would define most of its mission. Years of darkness. Years of falling outward through emptiness, past the orbit of Saturn, past Uranus, past Neptune, into a region no spacecraft had ever explored. It is hard to hold in your mind just how far it was going. The distance to Pluto at the time of the encounter was roughly 3 billion miles. Light itself, the fastest thing in the universe, takes well over 4 hours to cross that gap, which means that when the spacecraft finally arrived, it would be so far away that a radio signal sent from it, traveling at the speed of light, would take 4 hours and 25 minutes simply to reach the Earth. Think about what that delay means for the people running the mission. They could not steer the spacecraft in real time. They could not react to anything. By the time they saw a problem, it would already be hours in the past, and any command they sent in response would take another 4.5 hours to arrive. The spacecraft was, in the truest sense, on its own out there. After 9.5 years of travel, after 3 billion miles of patient falling through the dark, the moment finally came. On the 14th of July, in the year 2015, New Horizons swept past Pluto, and here is one of the cruelest details of the entire mission. The spacecraft was moving so fast, roughly 14 kilometers every second, that there was no possibility of slowing down and going into orbit. There was only one chance, a single flyby. The probe would scream past its target, gathering as much data as its instruments could capture in a few precious hours, and then it would continue onward into the dark, leaving Pluto behind forever. To collect the best images, the team had to point the spacecraft's cameras at Pluto rather than at Earth, which meant that during the most important moments of the entire mission, the probe could not even talk to home. It went silent. It gathered everything it could in that silence, storing it carefully in its memory, and then, only after the encounter was over, did it turn back toward the distant sun and begin the slow process of transmitting what it had found. Picture the control room now, on the night the signal is due. It is a room full of people who have given years of their lives to this single moment, and there is nothing left for any of them to do but wait. The spacecraft has already flown past Pluto. Whatever happened out there has already happened hours ago, 3 billion miles away. The data is already racing homeward at the speed of light. But light is not fast enough to spare them the waiting. So they sit and they watch the clock and they count down the 4 hours and 25 minutes that the universe demands. You can feel it in the room, the particular tension of a delay that no amount of money or genius can shorten, the helplessness of being separated from the thing you care about most by an unbridgeable gulf of distance. And then, at last, the signal arrives. A faint whisper of radio from the edge of the solar system, gathered by enormous antennas on Earth. The screens begin to fill. And the world that resolves on those screens is not the dead, cratered ball that everyone expected. It is something no one was prepared to see. There is something worth dwelling on in the sheer audacity of the mission, because it tells you a great deal about the distances involved. New Horizons was a small machine, weighing only a few hundred kilograms, roughly the mass of a grand piano, carrying a modest suite of instruments and a radio transmitter no more powerful than a household light bulb. With that faint transmitter, it had to send its data back across 3 billion miles of empty space. And the signal arriving at Earth was so weak by the time it crossed that gulf that it required some of the largest radio antennas humanity has ever built, great dishes tens of meters across, straining to gather a whisper of radio energy from the edge of the solar system. The data, came back slowly, agonizingly slowly, dribbling in at a rate far below what you would tolerate for a single photograph on your phone, so that the full treasure of the flyby took not hours, but many months to fully transmit. For more than a year after the encounter, new images of Pluto were still arriving, each one a fresh revelation, the spacecraft patiently emptying its memory across the void, one faint transmission at a time. And consider what it means that the spacecraft had to be aimed so precisely. To reach Pluto at all, after 9.5 years of flight, New Horizons had to arrive at a specific point in space at a specific moment, with Pluto itself moving along its own slow orbit. And the margin for error across 3 billion miles was astonishingly small. It is often compared to sinking a putt from one city to another, or hitting a target the size of a coin from thousands of miles away. That such precision is even possible, that human beings can fling a piano-sized machine across 3 billion miles of darkness and have it arrive exactly where a small frozen world will be a decade later, is one of the quiet triumphs of our species. And it was all in service of a single question: what is actually out there? What does the edge of the solar system truly look like when you finally get close enough to see it clearly? The answer, when it came, was worth every mile. What came back over those screens, slowly, image by image, in the hours and days that followed, would force a complete rewriting of what we thought a small frozen world at the edge of the solar system could be. Because Pluto, this object we had dismissed as a lonely dead misfit, turned out to be alive in the slow, patient way that only the outer solar system can be alive. It had mountains. It had plains so smooth they bore no scars at all. It had glaciers and faults, and the unmistakable signature of a world that was still, even now, even out there, in the killing cold, doing things. And to understand why that was so shocking, and what it began to reveal about the true nature of everything in the Kuiper Belt, we have to look closely at what New Horizons actually saw when it opened its eyes on that frozen heart at the edge of the dark. Part 3. The World That Should Have Been Dead. It is hard to overstate how completely this discovery upended expectations. In the months before the flyby, there were serious discussions about whether Pluto would turn out to be geologically quiet, a heavily cratered ball, little different from a large dead asteroid. The opposite happened. Pluto turned out to be one of the most geologically diverse and active bodies any spacecraft had ever visited, a useful reminder, woven through this entire story, of how often the outer solar system rewards us for looking, and how rarely it turns out to be as dull as our cautious expectations suggest. The first thing you need to understand about Pluto is just how cold it is, because the cold is not a detail. It is the whole context for why what New Horizons found was so astonishing. The surface temperature on Pluto hovers around minus 230 degrees Celsius. That is so cold that it is genuinely difficult for the human mind to hold. At that temperature, the very idea of what materials are supposed to do begins to fall apart. Water is not a liquid out there, and it is not even the brittle ice you scrape off a windshield. At minus 230 degrees, water ice becomes as hard and as strong as rock. You could build mountains out of it. And as we will see, Pluto has done exactly that. Pluto itself is small, with a diameter of roughly 2,370 kilometers, which makes it smaller than our own moon. It carries with it a thin, delicate atmosphere, made mostly of nitrogen with traces of methane and carbon monoxide. An atmosphere so tenuous that the pressure at the surface is roughly 100,000 times lower than the air pressure you are breathing right now. By every reasonable expectation, a world this small and this cold should have frozen completely solid early in its history and stayed that way, a museum piece, unchanged for 4.5 billion years. That is what the textbooks predicted, and that is not at all what New Horizons found. When the images came back, the feature that immediately captured everyone's attention was a great, bright, heart-shaped region near Pluto's equator. The team named it Tombaugh Regio in honor of Clyde Tombaugh, the astronomer who discovered Pluto back in 1930. The heart was beautiful, instantly iconic, the kind of image that travels around the world. But it was when scientists looked closely at the left lobe of that heart that the real shock arrived. That lobe is a basin now called Sputnik Planitia, roughly 1,000 kilometers across and several kilometers deep, and its surface is almost perfectly smooth. There are no impact craters on it, none. Take a moment to appreciate how strange that absence is. The solar system is a shooting gallery. Over billions of years, every exposed surface gets pounded by impacts, and the number of craters on a surface is essentially a clock, a way of reading how old that surface is. The more craters, the older the terrain. A surface with no craters at all is a surface that is brand new, geologically speaking, one that has been wiped clean and resurfaced recently enough that nothing has had time to hit it. On a world that was supposed to be frozen dead for 4.5 billion years, finding a 1,000-kilometer plain with no craters was like opening an ancient tomb and finding fresh footprints in the dust. So what is resurfacing it? The answer is that Sputnik Planitia is not solid frozen rock. It is a sea of frozen nitrogen, and that nitrogen ice is slowly, ponderously churning. Heat rising from far within Pluto drives a process called convection, the same process that makes a pot of thick soup roll and turn on a stove, except here it unfolds across kilometers of nitrogen ice over enormous spans of time. The surface of the basin is divided into great polygonal cells, each one roughly 30 to 40 kilometers across, and these cells are the tops of slow convection currents. Warmer ice rises in the center of each cell, spreads outward, cools, and sinks back down at the edges. The entire surface overturns itself completely roughly once every 500,000 years. That is glacially slow by human standards, but on the timescale of the solar system, it is practically frantic, fast enough to erase every crater and keep the surface forever young. At the edges of this churning nitrogen sea rise mountains, and these mountains are made of water ice. Remember what the cold does. At minus 230 degrees, water ice is no longer soft. It has the mechanical strength of rock, and so these mountains stand tall and sharp, reaching heights of 3 to 4 kilometers, comparable to serious mountain ranges here on Earth. They are not volcanoes. They are not made of stone in the way Earth's mountains are. They are, quite literally, mountains of frozen water, as hard as granite, rising at the shore of a glacier of frozen air. Elsewhere on Pluto, New Horizons found bladed ridges of methane ice, strange formations called penitentes that stretch for hundreds of kilometers, and long tectonic faults, cracks in the crust running for hundreds of kilometers across the surface. Those faults are perhaps the most provocative clue of all, because of what they imply about the inside of Pluto. The leading explanation for them is that Pluto has, or had, a subsurface ocean, a layer of liquid water buried beneath its frozen shell, perhaps mixed with ammonia, acting as a kind of antifreeze to keep it liquid at such low temperatures. As that buried ocean slowly freezes over time, the water expands, just as water expands when it freezes in a crack in a sidewalk, and that expansion pushes outward on the shell from below, cracking it and producing exactly the kind of extensional faults that New Horizons photographed. The heat needed to keep such an ocean from freezing entirely could come from the residual radioactive decay of elements in Pluto's rocky core, the same kind of internal warmth that keeps the Earth's interior molten. If this picture is correct, then Pluto, this tiny frozen world 3 billion miles from the Sun, may harbour a hidden sea of liquid water even today. I want you to sit with what that means for a moment, because it quietly overturns one of our deepest assumptions. We tend to think of the outer solar system as a place where nothing happens, a frozen graveyard where the only events are the slow accumulation of impacts over eternity. We think of cold as a synonym for dead. But Pluto is cold beyond anything in your experience, colder than any freezer, colder than the dark side of the moon. And Pluto is not dead. It convects. It builds mountains. It cracks its own crust from within. It may hide an ocean. The lesson Pluto teaches, the lesson that changes how you have to think about everything else out there, is that cold is not the same as dead, and that distance from the sun does not mean stillness. Whatever quiet machinery is turning inside that small frozen world has been turning for billions of years, in the dark, without an audience. And it was turning long before any human looked up and gave it a name. And it is turning still. There is more to Pluto's restless surface than the great nitrogen sea, and each detail deepens the picture of a world that refuses to be still. Across parts of Pluto, New Horizons found terrain that looks almost like the skin of a snake or the bark of a tree. Enormous fields of bladed ridges standing like rows of frozen knives, some of them hundreds of meters tall, marching across the terrain for hundreds of kilometers. These are thought to be made of methane ice, sculpted over long ages by sublimation, the slow turning of ice directly into vapor, which carves the surface into these strange parallel blades, the way wind and water carve ridges into the deserts and snowfields of Earth, only far slower and far stranger. Elsewhere there are dark, reddish regions near the equator, stained by tholins, the same organic compounds we will meet again and again on these frozen worlds. And running across the surface are the long faults, the cracks in the crust, evidence of a world whose shell has been stressed and stretched from within. The atmosphere of Pluto holds its own quiet drama, tied to the shape of its orbit. Pluto does not travel in a tidy circle. Its orbit is markedly stretched, an ellipse that carries it from about 29.7 astronomical units from the Sun at its closest approach to about 49.3 astronomical units at its most distant, over the course of a single Plutonian year that lasts 248 Earth years. As Pluto swings closer to the Sun, the faint warmth is enough to coax some of its surface ices into gas, and the thin atmosphere thickens. As it swings away again into the deeper cold, much of that atmosphere may freeze back onto the surface, collapsing almost entirely, snowing the air back down onto the ground. It is, in effect, a single, enormous, slow breath, inhaled and exhaled over the span of nearly 2.5 centuries, a planet-wide respiration so gradual that no human life is long enough to watch a full cycle. When New Horizons arrived, it caught Pluto with its atmosphere extended, layered with delicate blue hazes of tholin particles, glowing softly in the backlit sun, a sight so beautiful that it is difficult to reconcile with the brutal cold that produced it. And Pluto, remarkable as it is, does not travel alone. It has a companion so large that the two of them are better thought of not as a planet and a moon, but as a pair, a double world locked in a slow, eternal dance. That companion has secrets of its own, and one of them involves a kind of chemistry being performed across the empty vacuum between two worlds, which is where we turn next. Part 4. Touching the birth of the solar system. Before we leave Pluto behind, we have to meet its partner, because the relationship between them is unlike anything in the inner solar system. Charon is enormous relative to Pluto. Its diameter is roughly 1,212 kilometers, which is more than half the diameter of Pluto itself. No other moon in the solar system is so large compared to the world it orbits. The two are so closely matched that they do not really behave like a planet and a satellite at all. Instead, they orbit a common point in space that lies between them, a balance point called the barycenter, completing one full circle every 6.4 days, separated by only about 19,600 kilometers. They are mutually tidally locked, which means each one forever shows the same face to the other, like two dancers holding hands and turning slowly in place, each one staring eternally into the other's eyes. Charon hides a quiet wonder at its north pole, a dark reddish stain that the team informally nicknamed Mordor Macula, after the shadowed land in Tolkien's stories. For a while, its origin was a mystery, but the explanation that emerged is one of the most beautiful and strange ideas to come out of the entire mission. Pluto's thin atmosphere is constantly leaking. Methane gas escapes from Pluto into space, and some of it drifts across the gap to Charon, where it is captured by the brutal cold of Charon's pole, freezing onto the surface. There, exposed to ultraviolet light over long ages, that methane is slowly chemically transformed into reddish organic compounds, building up the dark polar deposit grain by grain over millions of years. It is, in a very real sense, atmospheric chemistry conducted across the open vacuum of space, one world exhaling and another world catching its breath and turning it into color. Charon also bears an immense canyon system, a series of chasms running over 1,000 kilometers and reaching depths of up to 9 kilometers, roughly 5 times deeper than the Grand Canyon, and likely carved, like Pluto's faults, by a freezing subsurface ocean cracking the crust from within. But Pluto and Charon, for all their drama, were not the final surprise New Horizons had to offer. After the flyby, the spacecraft was still healthy, still racing outward, and the mission team chose a second target, a much smaller and far more ancient object deeper in the Kuiper Belt. And to reach it, New Horizons had to perform one of the most precise acts of navigation in the history of exploration, threading a path to a tiny object only a few tens of kilometers across, in a region so empty that the nearest comparable body might be 50 million kilometers away. On the first day of January, in the year 2019, it succeeded. It flew within roughly 3,500 kilometers of an object officially designated 486958 and given the name Arakoth. Arakoth is small, only about 36 kilometers from end to end, and it orbits in the cold classical belt at a distance of around 44 astronomical units, the same general region where that very first Kuiper Belt object was found back in 1992. When New Horizons sent back its images, they revealed a shape that looked almost comical at first glance, like a snowman or a flattened peanut. Arakoth is 2 distinct lobes joined together at a narrow neck. The larger lobe is roughly 22 kilometers across, the smaller about 14, and the two of them are stuck together, touching, forming what astronomers call a contact binary. It was the first contact binary ever seen up close, and its surface was smooth and almost entirely free of craters, stained a uniform dark red by the same kind of irradiated organic ices that color so much of the outer solar system. What makes Arakoth precious, beyond almost any other object we have ever visited, is its age, or rather, its lack of change. This is a body that has been sitting quietly in the cold classical belt, undisturbed, since essentially the birth of the solar system 4.5 billion years ago. It has not been heated by the Sunday. It has not been smashed by major collisions. It has not been gravitationally stirred or scattered. It is, as close as anything we have ever found, a pristine relic of the original material from which the planets were built, a fossil of the solar nebula, frozen at the moment of creation and preserved untouched ever since. To look at Arakoth is to look directly at the raw ingredients of world building, exactly as they were before our planet, before the sun settled into its steady burn, before there was anyone to wonder about any of it. And the way Arakoth came together tells us something profound about how all worlds, including our own, are made. For a long time, One of the leading ideas was that planets grew through violent collisions, smaller bodies smashing into each other at high speed and somehow sticking, building up larger and larger objects through a kind of cosmic demolition derby. But Arakoth tells a gentler story. Its two lobes are not shattered or deformed in the way a high-speed collision would leave them. Instead, every line of evidence suggests that the two pieces drifted together extraordinarily slowly, at a speed of only a few meters per second. That is slower than you can jog. Two mountains of ice and dust, each many kilometers across, approaching each other slower than a person walks, until they gently touched and stayed together, held by their own faint gravity. Let yourself drift back 4.5 billion years, and stand, in your imagination, on the surface of one of those two lobes before they have met. Around you there is no sun as you know it, only a faint, distant brightening in a sky crowded with the raw material of a forming solar system. You are standing on a soft, dark mountain of ice and pebbles and frozen gas, and through the slow dark you can see the other lobe approaching, a second mountain looming nearer across the years, not falling, not rushing, but easing toward you at the pace of a slow walk. There is no sound, because there is no air to carry it. There is no violence, no crash, no fire. There is only the patient, silent closing of a gap over years, until at last the two surfaces meet and settle against each other with the faintest possible contact, a touch so gentle it would not disturb dust. And then nothing moves. The two lobes hold together, locked in that final embrace, and around them the rest of the forming solar system slowly clears, and the cold deepens, and 4.5 billion years pass in stillness, until a machine the size of a piano slides past in a single second, takes a few hundred photographs, and carries the memory of that ancient, silent touch all the way back to Earth. The shape of Arakoth carries its own puzzle, one that reminds us how much we still do not understand even about the objects we have visited up close. Both of its lobes are not round, as you might expect two gently merged spheres to be. They are distinctly flattened, like a pair of pancakes or a dented walnut lying against each other. When scientists ran their models of how a body should form through the slow gravitational collapse of a pebble cloud, the models tended to predict rounder shapes, not these curiously flattened lobes. So even Arakoth, our most pristine and best-studied relic of planetary birth, holds a detail that does not quite fit our theories, a small reminder that the process by which worlds are made is still not fully understood. In early 2026, researchers ran new simulations of spinning clouds of pebbles collapsing under their own gravity, trying to reproduce exactly this kind of two-lobed, flattened shape. And the work is ongoing. The fossil has been recovered, but we are still learning to read it. There is also a growing sense that Arakoth's kind of gentle pairing is not the end of the story. In early 2025, astronomers studying another Kuiper Belt object found evidence that what had appeared to be a simple pair of bodies might in fact be a triple system, 3 objects bound together, which would make it only the second known triple system in the entire belt. If gentle gravitational collapse is the dominant way these bodies form, then we should expect not just pairs, but more complex groupings, and finding them would be further confirmation that the streaming instability, the quiet gathering of pebbles, is how the building blocks of planets came together. Each such discovery adds another line of evidence that the Kuiper Belt is not just a graveyard of leftover ice, but a preserved record of the gentlest and most fundamental process in the making of worlds. That gentle assembly is now understood through an idea called the streaming instability, in which enormous clouds of small pebbles in the early solar system gather and collapse under their own gravity directly into larger bodies, rather than building up through violent impacts. Arakoth is the strongest physical evidence we have that this is how it really happened, and contact binaries, like it appear to be common in the Kuiper Belt, with studies suggesting that somewhere between 10 and 30% of small objects out there may be two pieces gently joined, which means that scattered across that frozen wing of the house, by the hundreds of millions, are these quiet monuments to the gentleness of creation, each one recording a moment when two pieces of the early solar system reached out across the dark and touched. And every one of them is made of the same primordial material that, closer to the sun, gathered itself into the ground beneath your feet. Part 5. What it is really made of. We have spent the first part of this journey following the spacecraft, letting the discoveries arrive in the order that history delivered them. Now I want to slow down and ask the question at the center of everything, the question in the title, directly. What is the Kuiper Belt actually made of? Because the textbook answer, a belt of icy bodies, is true the way the word water is true for the ocean. It is correct, and it tells you almost nothing about what it would actually be like to be there. Start with the word ice, because it is doing far more work than you might think. When you hear ice, you picture frozen water, the cubes in a glass, the frost on a window. But in the Kuiper Belt, ice is a category, not a substance. Out there, at temperatures of roughly minus 220 to minus 240 degrees Celsius, many things that you only ever encounter as gases or liquids become solid, become rock hard, become building materials. There is water ice, yes, but there is also methane ice, and ammonia ice, and carbon monoxide ice, and nitrogen ice. The nitrogen is the one I want you to hold on to, because nitrogen is not some exotic chemical. Nitrogen makes up about 78% of every breath you take. The air filling your lungs at this very moment is mostly nitrogen. And out in the Kuiper Belt, that same nitrogen lies frozen on the ground, hard enough to walk on, slow enough to flow like a glacier over thousands of years. The very air you breathe is, out there, a kind of stone. This is the thing that the simple phrase, icy bodies, hides from you. The Kuiper Belt is not made of some alien matter we have never encountered. It is made of the most familiar substances in your life, the water you drink, the air you breathe, the carbon and the simple organic molecules that make up living things, all of them transformed by the cold into something unrecognizable. The cold is so absolute that it rewrites the rules of ordinary materials. Water ice gains the strength of granite and builds mountains. Carbon dioxide, the gas you exhale, becomes a hard frost. Methane forms pale crystalline ridges. Steel, if you brought it out there, would become so brittle it could shatter like glass. Rubber would crumble to powder. The familiar physics of warm, wet, living earth simply does not apply, and in its place is a frozen chemistry where the soft becomes hard and the breathable becomes solid ground. I find this to be one of the quietly unsettling truths of the whole subject, and I want to give it room. Everything your body needs to stay alive, the water in your cells, the oxygen and nitrogen moving through your lungs, the warmth that keeps your blood liquid, all of it exists 4 billion miles away, only as construction material. The water is mountains. The air is bedrock. The temperature that would freeze you solid in seconds is simply the ambient condition, the everyday state of things, no more remarkable out there than a mild afternoon is to you. There is no malice in it. The Kuiper Belt is not hostile in the way a predator is hostile. It is something stranger and more humbling than that. It is utterly indifferent, a place where the substances that mean life to you mean nothing at all, where they are just frozen materials lying in the dark, and where you and everyone you have ever known simply could not be. The chemistry that makes you possible runs out there in reverse, and the universe does not notice the difference. The surfaces of these worlds carry a signature of their long exposure to the dark, and it shows up as colour. Many Kuiper Belt objects are stained a dark brick red, and that colour has a story. When ultraviolet light from the distant sun and high-energy cosmic rays streaming in from the wider galaxy strike the methane and nitrogen ices on these surfaces over billions of years. They break apart the simple molecules and reassemble them into complex, heavy organic compounds called tholins. These tholins are reddish-brown, sticky, tar-like substances, and they are the same general family of molecules that many scientists believe were important precursors to the chemistry of life. So the outer solar system is not just frozen, it is slowly cooking in the cold and the dark, a kind of organic chemistry set running at a pace measured in eons. The redness you would see if you stood on one of these worlds is the visible record of that ancient, patient chemistry. Imagine, for a moment, that you could stand on the surface of one of these objects, protected somehow from the cold, and simply look around and touch what is there. Beneath your boots is not soil and not the white ice of a frozen lake, but a dark, reddish crust, the colour of dried blood or old brick, crunching faintly underfoot. You kneel and press your gloved hand against the ground, and it does not yield at all. This is water ice, but it is harder than the stone of any mountain on earth, immovable, ringing faintly if you were to strike it. A little way off, a broad, pale plain stretches toward the horizon, and that plain is frozen nitrogen, the same gas filling your lungs, lying here as a wide field of ice that creeps forward a few centimeters in a year. Above you, the sky is utterly black, even in the middle of the day, and somewhere in that blackness is the sun, no longer a disk you could not bear to look at, but a single piercing point of light, brilliant and small, a bright star that has lost all its warmth and all its authority. You are standing on the air you breathe and the water you drink, both turned to stone in the light of a sun reduced to a star, and the silence is total, because there is no air here to carry any sound at all. The colour of these worlds turns out to be more than a curiosity, because it works as a kind of fingerprint, a way of reading where each object formed and what it has been through. Not every Kuiper Belt object is the same shade of red. Some are a dark, intense brick red, and others are far greyer, closer to neutral, and that difference is not random. The reddest objects tend to be the ones in the cold classical belt, the gently orbiting bodies that formed far from the sun and have sat undisturbed in the profound cold for the entire age of the solar system, accumulating their tholin stains over 4.5 billion uninterrupted years. The greyer objects tend to be the ones that were scattered from regions a little closer to the sun, where their surfaces were processed differently, or that have had fresher material exposed by collisions. So, when an astronomer measures the precise colour of a distant point of light in the Kuiper Belt, they are reading a biography. The colour tells them, in broad strokes, where that world was born and how violent its history has been. In a region where we can resolve almost nothing as more than a single pixel of light, colour becomes one of the only ways we have to tell these hundreds of millions of worlds apart, to sort them into families, and to reconstruct the ancient history of the outer solar system from nothing but the tint of reflected sunlight. It is worth lingering, too, on just how absolute and physics-bending the cold truly is, because the numbers do not really convey it until you imagine the consequences. At minus 230 degrees Celsius, you are only about 40 degrees above absolute zero, the coldest temperature that is physically possible, the point at which all thermal motion very nearly ceases. At that temperature, ordinary matter behaves in ways that would seem like magic in a warm laboratory. Gases you think of as impossible to solidify lie frozen on the ground. Materials that are tough and flexible on Earth become brittle and shatter at a touch. Chemical reactions that proceed in an instant in your kitchen slow to a crawl that might take millions of years. Time itself, in a sense, runs differently for chemistry out there, every process stretched and slowed by the lack of heat. The Kuiper Belt is not just cold the way a winter night is cold. It is cold in a way that fundamentally changes what matter is allowed to do, a cold so profound that it freezes not only the substances but the very pace of change, holding these worlds in a kind of suspended animation that has lasted since the birth of the Sunday. So when someone asks what the Kuiper Belt is made of, the fullest answer is this. It is made of the ingredients of you and of the Earth and of the inner solar system, frozen so deeply that they have become alien. It is made of water and air and the building blocks of organic chemistry, all of it locked into hundreds of millions of dark red worlds, none of them warm enough for any of it to do what it does on Earth. It is a frozen inventory of everything that matters to life, kept in a cold so complete that life is impossible. And the strangest part, the part we are building toward, is that this frozen, indifferent place is not as still or as simple or as finished as we long believed. But before we can understand the ways it surprises us, we have to confront the sheer scale of it, because the Kuiper Belt is not the tidy ring those diagrams always draw. It is something far larger, far emptier, and far harder to picture than a ring could ever be. Part 6. The belt is not a ring. Every diagram you have ever seen of the Kuiper Belt does it a disservice. It draws a flat, tidy ring, a thin band of dots circling neatly just outside Neptune's orbit, like the rings of Saturn scaled up. And that picture creates two false impressions at once. It makes the belt look thin, and it makes it look crowded. The truth is the opposite on both counts. The Kuiper Belt is not thin, it is enormously thick, a three-dimensional shell rather than a flat ring, and it is not crowded at all. It is one of the emptiest places it is possible to imagine. So empty that the word belt, which suggests something packed and continuous, is almost a lie. Let us deal with the size first. The main body of the belt begins near 30 astronomical units at the orbit of Neptune and extends outward to at least 50 astronomical units. Remember that 1 astronomical unit is about 93 million miles, the distance from the Earth to the Sunday. So the inner edge sits roughly 2.8 billion miles from the Sun, and the classical outer edge lies around 4.6 billion miles out. That main body spans about 20 astronomical units in width. To put that in perspective, the entire stretch of planets, from Mercury all the way out to Neptune, covers about 30 astronomical units. So the width of the Kuiper Belt alone is about 2/3 of the width of the entire planetary solar system. This single feature, the one left as a blank margin on the diagrams, is nearly as wide as everything else put together. Numbers like that tend to slide off the mind, so let me give you something to hold on to. Imagine you could drive a car out to the Kuiper Belt at a steady highway speed, say 100 kilometers an hour, never stopping, never sleeping, just driving. Starting from the Sun, it would take you over 5,000 years of continuous driving just to reach the inner edge of the belt. 5,000 years. That is longer than all of recorded human history. And then, having arrived at the inner edge, you would need to keep driving for another 2,000 years to cross from the inner edge to the outer edge. The belt is so enormous that crossing its width alone at highway speed would take twice as long as the time that has passed since the building of the pyramids. Now add the third dimension, the one the flat diagrams erase entirely. The belt is not a thin ring lying in a single plane. It is a thick torus, a three-dimensional donut, with objects on orbits tilted at many different angles, some hugging the plane of the planets, others swooping high above and far below it. When you account for that thickness, the volume of space the belt occupies becomes almost incomprehensible. The sphere, enclosed by the Earth's orbit, the entire region from the Sun out to where our planet circles, is already a volume great beyond imagining. The Kuiper Belt occupies a volume roughly 100,000 times larger than that, 100,000 times the volume of the Earth's entire orbital sphere, filled with a sparse scattering of frozen worlds. There is one more way to feel the scale, and it involves light, because light is the fastest thing there is, and even light struggles with these distances. A beam of sunlight leaving the surface of the Sun takes only about 8 minutes to reach the Earth. To reach the inner edge of the Kuiper Belt, that same beam of light must travel for more than 4 hours. And here is what that does to the Sun, as seen from out there. At a distance of 40 astronomical units, the sunlight is roughly 1/1600th as intense as it is at Earth. At 50 astronomical units, it falls to about 1/2500th. The Sun, which dominates our sky so completely that we cannot look at it without pain, shrinks at those distances to a point so small that your eye could no longer resolve it as a disk at all. It would be a single, intensely bright star, brighter than any other star in the sky, but a star nonetheless, casting a light more like a full moon's than like daylight. The warmth would be gone entirely. You could stare at it directly without flinching. The center of our solar system, the source of all its light and life, reduced from a blazing sphere to a brilliant point, is itself one of the quiet shocks of the outer dark. And that word sparse is the key to the second false impression, the impression of crowding. Yes, the belt contains hundreds of millions of objects, but spread those hundreds of millions of objects across a volume 100,000 times the size of Earth's orbital sphere, and they are not packed together at all. They are profoundly, almost perfectly isolated. The average distance between two large Kuiper Belt objects is on the order of tens of millions of miles. To give that number a familiar shape, consider that the closest Mars ever comes to Earth is about 34 million miles, a distance so great that even our fastest spacecraft take many months to cross it. The typical gap between neighbouring worlds in the Kuiper Belt is comparable to that, or greater. If you were standing on the surface of one Kuiper Belt object, the nearest large neighbour would not be a looming presence in your sky. It would not be visible at all. It would be tens of millions of miles away, lost entirely in the black, indistinguishable from the stars. Picture it from the surface then. You are standing on a frozen world somewhere in the middle of the belt, and you look up, expecting perhaps the crowded sky of those diagrams, a sky full of tumbling, icy worlds. But the sky is empty, utterly empty. There are stars, sharp and unblinking, because there is no atmosphere to soften them. There is the sun, that single brilliant point, casting almost no warmth. And there is nothing else. No neighbouring world hangs overhead. No companion drifts past. The hundreds of millions of objects that share this region with you are all so far away that not one of them can be seen. You are surrounded by company, in the sense that this is the most populated region of the solar system, and yet you are more alone than you could be anywhere on Earth. More alone than at the bottom of the deepest ocean or the centre of the largest desert, because here the nearest neighbour is millions of miles of vacuum away, and the silence is the silence of a place where nothing has ever made a sound. It helps to compare the Kuiper Belt with the only other belt most people have heard of, the asteroid belt, because the comparison corrects another false impression that science fiction has planted in our minds. In films, the asteroid belt is a churning hazard, a dense field of tumbling rocks so closely packed that a spaceship must weave frantically to avoid being crushed. The reality is almost comically different. The asteroid belt, lying roughly between 2 and 3 1/3 astronomical units from the Sun, is made mostly of rock and metal rather than ice, and it is so sparse that spacecraft routinely fly straight through it without any danger at all. Its total mass is only about 4% of the mass of our Moon. The Kuiper Belt is far larger, far colder, and contains far more objects, so many that the asteroid belt could fit inside it thousands of times over, and yet, spread across such a great volume, it is emptier still. If the asteroid field of the movies is a myth, the Kuiper Belt is the myth turned inside out, a region with hundreds of millions of members where you could travel for a lifetime and never come close to any of them. To grasp the volume in another way, consider that the belt is not a band, but a shell with real depth, with objects riding on orbits tilted at every angle, some staying near the flat plane where the planets travel, and others swinging far above and below it. If you could somehow see all of them at once, glowing, the Kuiper Belt would not look like Saturn's rings viewed edge-on. It would look more like a thick, diffuse, donut-shaped haze surrounding the inner solar system, fattest near the plane of the planets, but reaching well out of that plane in every direction. And within that haze, the worlds would be so widely separated that the haze itself would be mostly illusion. A statistical glow made of points so far apart that no two of them would ever appear close together. The belt is real, and it is enormous, and it is almost entirely empty, all at the same time. And holding those three truths together in your mind is the beginning of understanding what kind of place it really is. This is the truer meaning of the word terrifying as it applies to the Kuiper Belt. It is not crowded with danger, it is the opposite. It is so empty and so enormous and so cold that it dissolves the human reference points we use to feel located in the world. On Earth, there is always a horizon, always a landmark, always some sense of near and far. In the Kuiper Belt, there is none of that. There is only volume and dark and a scattering of worlds too far apart to ever meet. It is the emptiness, not any object within it, that unsettles. And yet, and this is the strange turn the story keeps taking, this enormous empty frozen place is not as inert as its emptiness suggests. Things happen out there, things we did not expect. To understand why, we first have to understand how this whole enormous region came to be the way it is, because the belt we see today is not the belt that once existed. It is a remnant, a ruin, of something that was once far larger and far more crowded, and the story of what happened to the rest of it is the story of how the outer solar system was sculpted. Part 7. How it got this way. To understand what the Kuiper Belt is made of, you eventually have to ask how it came to be, because its composition and its arrangement are both records of an ancient and violent history. And the first thing to know is that the belt we see today is not the belt that originally formed. It is a faded remnant, a small fraction of what once was, the survivors of an upheaval that reshaped the entire outer solar system billions of years ago. When the sun was young, it was surrounded by a flattened disk of gas and dust, the solar nebula, and out of that disk the planets slowly gathered. Far from the sun, beyond a boundary astronomers call the frost line, it was cold enough for water and other volatile compounds to freeze into solid grains, and so the outer disk was abundant in ices. In that distant region, countless small, icy bodies condensed, the planetesimals, the seeds of worlds. The original outer disk of these bodies was not the sparse belt we know now. It was dense, and it stretched roughly from 15 to 30 astronomical units. And it contained an astonishing amount of material, perhaps trillions of small, frozen bodies, and many times the mass of all the objects in the belt today. Then something disturbed the calm. The leading explanation for what happened next is a framework known as the Nice model, named after the French city where it was developed. In this picture, the giant planets, Jupiter, Saturn, Uranus, and Neptune, did not form in the orderly, widely spaced orbits they occupy today. They formed closer together in a more compact arrangement, and for a long time their configuration was stable. But the giant planets were embedded at the inner edge of that massive disk of icy planetesimals, and over time their gravitational interactions with all that material slowly changed their orbits. Eventually, the system crossed a tipping point, and the careful balance collapsed into chaos. The orbits of the giant planets shifted dramatically over tens of millions of years, and Neptune in particular began to migrate outward, ploughing into the dense disk of icy bodies like a snowplow driving into a thick drift. The consequences were enormous. As Neptune migrated outward, its gravity flung the icy planetesimals in every direction. Many were hurled inward toward the Sun, and some of those triggered a period of intense bombardment that cratered the Moon, Mercury, and Mars, the scars of which we can still read on their surfaces today. Many others were thrown the opposite way, ejected entirely from the solar system, cast out into interstellar space, never to return. Some were captured into stable resonances with Neptune, locked into orbital rhythms that protected them, and a relatively small number survived in place in the cold outer reaches, becoming the Kuiper Belt we observe now. The crucial point is that the modern belt contains only a few % of the mass that originally occupied the outer disk. The rest was scattered, ejected, or driven inward. What we see today is the small remainder, the survivors of a great dispersal. This history is written directly into the structure of the belt, in patterns that astronomers can read like the rings of a tree. There is a group of objects, including Pluto itself, that are locked in what is called a 2 to 3 resonance with Neptune, meaning they complete 2 orbits for every 3 that Neptune completes. This rhythmic relationship shields them from close encounters with the giant planet, and these objects are called the Plutinos. There is the cold classical belt, occupying relatively circular, gently tilted orbits between roughly 42 and 47 astronomical units. And these are the least disturbed objects of all, the ones that likely formed close to where they now sit and were never violently scattered. They tend to be the reddest objects, because they have sat undisturbed in the profound cold the longest, accumulating their tholin stains over the full age of the solar system. Arakoth, that pristine relic we visited, belongs to this cold, classical population, which is exactly why it is so undisturbed. Then there is the hot classical belt, objects at similar distances but on more steeply tilted and stretched orbits, which tend to be greyer, suggesting they were processed nearer the Sun before being scattered outward. And finally there is the scattered disk, objects on wildly eccentric orbits that carry them from near Neptune out to hundreds of astronomical units, the most thoroughly flung of all the survivors. There is a beautiful subtlety hidden in all of this. The individual objects of the Kuiper Belt are ancient, every one of them about 4.5 billion years old, formed in the earliest days of the solar system, but their orbits, their addresses, are younger. The arrangement we see, the resonances, and the classical belt and the scattered disk was imposed later during the Great Migration roughly 4 billion years ago. So when you look at the belt, you are looking at very old objects that were rearranged into a slightly younger pattern. The bodies are originals. The filing system is a revision. The frozen worlds themselves remember the birth of the Sun, but the shape of the belt remembers the catastrophe that came after. It is worth slowing down on the human side of this discovery, because the confirmation of the belt was not a single triumphant moment, but a long act of stubborn patience that almost did not happen. When Dave Jewett and Jane Liu set out in 1987 to search for objects beyond Neptune, they were chasing something that most of their colleagues thought might not even be there. The prevailing assumption was still that the region was empty, that Pluto was an oddity, that there was nothing to find. So they searched, night after night, using the telescopes on Mauna Kea, comparing images of the same patch of sky taken hours apart, looking for the one faint point of light that had shifted position against the fixed background of stars, the telltale sign of a nearby object orbiting the Sunday, and for 5 years they found nothing. 5 years of cold nights and careful work and disappointment, hunting for a thing that might be a phantom. It would have been entirely reasonable to give up. But they did not, and on that night, in August of 1992, the patience paid off, and a single faint smudge shifted where it should, and the entire outer solar system changed in an instant from a blank space into a frontier. There is a lesson in that, about how often the largest discoveries hinge on someone refusing to stop looking at an empty-seeming sky. The Nice model also explains something we might otherwise find puzzling, which is the sharpness of the belt's inner boundary. The main body of the Kuiper Belt begins quite abruptly near 30 astronomical units, right at the orbit of Neptune, almost as if something had swept the region cleaner, closer in. And that is essentially what happened. Neptune, the great architect of the outer solar system, has cleared and shaped the space around its own orbit through its gravity, scattering away or capturing the objects that strayed too close, leaving a relatively sharp edge where its influence dominates. The Plutinos, locked in their protective 2 to 3 resonance with Neptune, survive precisely because their orbital rhythm keeps them from ever getting too close to the giant planet at the wrong moment. Everything about the structure we observe, the sharp inner edge, the resonant populations, the scattered disk, bears the fingerprints of Neptune's migration. The belt is not a random scattering of leftover ice. It is a sculpture, and Neptune was the sculptor, and the chisel was gravity, and the work was done across tens of millions of years, roughly 4 billion years ago. And this is why the Kuiper Belt is sometimes called a fossil of the solar nebula. It preserves, in its composition and its structure, the record of how our planetary system was assembled and then violently rearranged. The ices tell us what the outer disk was made of. The colours tell us where each object formed and how long it has been exposed. The orbits tell us the story of Neptune's migration and the dispersal of trillions of bodies. To study the belt is to perform a kind of archaeology on the solar system itself, reading the ancient past in the frozen present. But here is the unsettling thing, the thread that we have been circling and are now ready to pull. Even after all this study, even after we thought we understood the belt's edges and its limits, the solar system still had a surprise waiting, one that came not from a grand telescope or a famous flyby, but from a small instrument built by students, quietly counting grains of dust at the edge of everything. Part 8. The dust that wouldn't stop. Among all the instruments aboard New Horizons, there is one that is easy to overlook because it does not take photographs, and it was not the reason the mission was funded. It is called the Venetia Burney Student Dust Counter, and it has a charming origin because it was designed and built largely by students at the University of Colorado Boulder. Its job is simple and humble. As the spacecraft flies through space, this instrument registers the tiny impacts of dust grains striking it, microscopic specks of debris, and it counts them and measures their sizes. Across the great emptiness of the outer solar system, it has been quietly tallying the rare collisions of dust against the spacecraft's body, building up a census of just how much fine debris is out there at each distance from the sunday. The reason this matters is that dust in the Kuiper Belt is not random. It is produced by the objects themselves, ground out by the slow, occasional collisions between Kuiper Belt bodies and worn off their surfaces over time. So the amount of dust at any given distance is a kind of indirect measure of how many parent bodies are out there producing it. Where there are many objects, there should be more dust. Where the population thins out, the dust should thin out too. And here is the prediction that everyone expected the instrument to confirm. As New Horizons approached the supposed outer edge of the classical Kuiper Belt, somewhere around 50 astronomical units, the population of objects was believed to drop off sharply, falling away into the near emptiness of the scattered disk. So the dust count should have fallen too. The instrument should have measured the signal fading away as the spacecraft crossed the edge of the belt and headed out into the truly empty void beyond. That is not what happened. As New Horizons pushed outward, past 40 astronomical units, past 45, approaching 50, and then beyond, the dust did not fade. The readings stayed stubbornly high. In the region between roughly 40 and 60 astronomical units, the instrument was measuring dust fluxes 2 to 3 times higher than the models had predicted, and the elevated signal continued through 55 astronomical units and onward. The dust counter was finding far more debris near and beyond the supposed edge of the belt than there had any right to be. The signal that was supposed to fade did not fade. It persisted. Something out there, past the line we had drawn on the map, was producing dust. When the team published these results in the Astrophysical Journal Letters in early 2024, they laid out the possible explanations, and every one of them is provocative in its own way. One possibility is that the radiation pressure of sunlight, faint as it is out there, is pushing dust grains outward from where their parent bodies actually live, stretching the dust distribution farther than the bodies themselves extend. Another is that icy dust grains undergo a process called photosputtering, which changes how strongly sunlight pushes on them, carrying them outward. But the most exciting possibility, the one that made headlines, is the simplest and the most unsettling. The belt may not end where we thought it did. The population of objects may extend much, much farther out than our observations have so far revealed. Or, even more provocatively, there may be a second, entirely separate population of icy bodies waiting out beyond the classical belt, a whole additional region that no one had ever mapped or even suspected. Imagine you are aboard New Horizons in those moments. Or rather, imagine you could feel what the spacecraft was registering. You have crossed the Great Belt. You have flown past Pluto, past Arakoth, past the dense core of the classical Kuiper Belt. The map says you are now leaving it behind, entering the thinning outer fringe where the worlds grow sparse and the dust should dwindle toward nothing. You are heading, the diagrams promise, toward emptiness. And so you wait for the silence to arrive, the falling off of impacts, the gradual hush that should mark the true edge of the solar system's populated zone. But the silence does not come. The faint, irregular patter of dust grains against your body keeps on, no quieter than before, sometimes louder than it should be. Mile after mile, astronomical unit after astronomical unit, the debris keeps arriving, telling you, without words, that there is still something out here, that the edge you were promised is not the edge at all, that the belt, or something like it, reaches on into a dark that no one has charted. The ending you expected refuses to begin. To appreciate why this finding is so significant, it helps to understand how rare and precious this kind of measurement is. The student dust counter is the only instrument of its kind ever to operate this far from the Sunday. No other spacecraft has ever carried a working dust detector across the Kuiper Belt, which means that every single reading it takes is a number we have never had before, a direct measurement from a region we have, otherwise only studied from billions of miles away through telescopes. When astronomers model the belt, they are usually inferring its properties indirectly from the faint specks of light they can catch from Earth. But New Horizons is actually there, physically embedded in the belt, and its dust counter is feeling the region directly, registering the real, physical impacts of real grains of debris. So when that instrument reports something that contradicts the models, it carries a weight that an Earth-based observation cannot, because it is not an inference. It is a measurement taken from inside the thing itself. The map said the territory should be empty here. The explorer who actually went there reports that it is not. There is also something poetic about the source of this discovery, and it is worth honouring. The instrument that may have found a new population of bodies in the solar system was built by students. Not by a famous laboratory, not by a team of senior scientists with decades of experience, but by undergraduate and graduate students at the University of Colorado Boulder, learning their craft by building a real instrument that would fly on a real mission to the edge of the solar system. The instrument is even named for Venetia Burney, the 11-year-old English girl who, back in 1930, suggested the name Pluto for the newly discovered world. So a device named for a child, built by students, flying farther from the Sun than almost anything humanity has ever sent, may have made one of the most surprising discoveries about the structure of our own solar system in a generation. There is a lesson in that about who gets to make discoveries and about how the universe rewards patient, careful attention from anyone willing to give it, regardless of how senior they are. This is one of those discoveries that quietly rearranges your sense of the whole map. We had drawn a boundary. We had said, here is where the Kuiper Belt ends. Here is the outer wall of this room in the house. And then we sent a probe to that wall, and it told us the wall is not there, or at least not where we put it. Recall the question we have been carrying since the beginning, where the map says it should end. We drew that line at 50 astronomical units with real confidence. And the dust counter, this modest instrument built by students, has turned that line from a fact into a failure, a place where our model of the solar system simply stops matching what is actually out there. Alan Stern, the principal investigator of the mission, suggested that this might be the first time any spacecraft has discovered an entirely new population of bodies in the solar system, though he was careful to add the necessary caution that dust grains, unlike worlds, carry no return address, so we cannot yet be certain exactly where they are coming from. There is something worth pausing on in how this discovery arrived. Dust is the smallest, humblest material in the solar system, the ground-up residue of collisions, the powder worn off the surfaces of worlds, and we do not usually think of it as a discovery at all. Yet the most important findings are often not the dramatic, expected ones, the close-up photographs and the famous flybys, but the quiet anomalies, the places where a careful measurement simply refuses to match the prediction. The Pluto images were glorious, but they were, in a sense, what we went looking for. The dust that would not fade was something we did not go looking for at all, something the solar system volunteered, and that may be why it matters so much. It is the universe quietly correcting our map without being asked. But the uncertainty is itself the point. We do not know where the Kuiper Belt ends. We sent a machine to find the edge, and it kept finding belt. And if the belt is larger than we thought, then so is the part of the solar system made of frozen, indifferent dark, and so is everything the title has been pointing at. The room is bigger than we drew it, and the dark beyond it is harder to find because it keeps receding as we approach. Part 9. The breath it shouldn't have. If the dust counter quietly suggested that the Kuiper Belt is larger than we thought, the next discovery suggested something even harder to accept, that it is more alive than we thought. And it concerns one of the smallest, most obscure objects in this entire story, a frozen body so minor that for most of its existence in our catalogues, it had nothing but a string of letters and numbers for a name. The object is designated 612533, and it also carries the older provisional designation 2002 XV93. It is a Plutino, one of those objects locked in resonance with Neptune, orbiting at a distance of about 40 astronomical units, and it is small. Its diameter is only about 500 kilometers, which makes it nearly 5 times smaller than Pluto. By every expectation we had, an object this small, this cold, and this far from the sun should be a simple, airless rock of ice. Small bodies have weak gravity, far too weak, we assumed, to hold on to any gas. Any atmosphere such a tiny world might once have had should long ago have drifted off into space. The textbook said, and it said it with confidence, that out here only Pluto, with its comparatively respectable size, was large enough to maintain even a wisp of atmosphere. Pluto was the exception, the one trans-Neptunian object with air. Everything smaller was bare. The way astronomers caught this tiny world in the act is itself a marvel of patience and precision, a technique called a stellar occultation. The idea is elegant. From time to time, a Kuiper Belt object, moving along its orbit, will pass directly in front of a distant background star as seen from somewhere on Earth. For a brief moment, the object blocks the star's light, casting a tiny shadow that sweeps across our planet. By stationing telescopes at carefully chosen locations and precisely timing how the star's light winks out and returns, astronomers can measure the size and shape of the object, even though it is far too small and far too distant to be seen as anything but a point. On the 10th of January, 2024, a team led by Ko Arimatsu of the National Astronomical Observatory of Japan observed exactly such an event. Watching this small Plutino pass in front of a star from multiple sites across Japan. And here is what they found. When an airless body passes in front of a star, the star's light cuts off sharply, instantly, like a switch being flipped, because there is nothing but hard surface and vacuum at the object's edge. But when this object passed in front of the star, the light did not cut off sharply. It dimmed gradually, fading and then returning in a smooth curve rather than a clean break. That gradual dimming is the unmistakable fingerprint of an atmosphere, a thin envelope of gas around the object that bends and dims the starlight as it passes through. From the precise shape of that dimming, the team derived a surface pressure for this atmosphere of roughly 100 to 200 nanobars. That is an extraordinarily thin atmosphere by any earthly standard, almost a vacuum. But it is real, and it is measurable, and crucially, it is more than prior limits had suggested such a small body could possibly hold. When they published the result in the journal Nature Astronomy in May of 2026, it represented the first detection of an atmosphere on any trans-Neptunian object beyond Pluto. Think about what that overturns. We had a clean rule. Pluto has an atmosphere because Pluto is big enough. Everything smaller is too small. And then a world 5 times smaller than Pluto, drifting 4 billion miles from the Sun, turned out to be wrapped in a thin breath of gas that, by our rules, it should not be able to keep. The likely components are methane, nitrogen, or carbon monoxide, the same frozen volatiles that make up so much of the belt. And the deepest question is where that gas is even coming from, because a body this small could not have retained a primordial atmosphere over billions of years. One leading idea is that the atmosphere is being actively replenished from below by cryovolcanism, a kind of cold volcanism in which gases and ices erupt from the interior, suggesting the object is geologically active. Another is that a recent impact released a temporary puff of gas that we happened to catch. Either way, the implication is the same, and it is remarkable. This is not a dead rock. Something is happening on it. Now, in our era, on a small, frozen world at the edge of the solar system. I keep returning, in my own mind, to the strangeness of this, and I want to share why it stays with me. Out there, 4 billion miles away, in the cold and the dark, on an object so small and so obscure that until recently it had no name at all, only a catalogue number, there is a world exhaling. A thin, faint breath of gas it has no right to hold, escaping and perhaps being replenished, rising from a surface that no human will ever stand on, beneath a sky where the sun is just another star. No one is watching it out there. Nothing depends on it. And yet it is doing something, performing some quiet chemistry or geology in the indifferent dark, and it has presumably been doing it for a very long time, entirely unwitnessed, entirely unsuspected, until a careful team in Japan caught the shadow of a star bending around it for a few seconds one night in 2024. The lesson is humbling and a little unnerving. The Kuiper Belt is full of objects we have dismissed as inert, hundreds of millions of them, and we have just learned that at least one of the smallest is alive with activity we did not predict. How many others are breathing out there in the dark, doing things we have never seen, simply because we have never looked closely enough? It is worth appreciating the delicacy of the technique that caught this, because the stellar occultation is one of the most clever and least appreciated tools in all of astronomy. The object itself is far too small and far too distant to be seen as anything but a single point, even with our best telescopes. We cannot photograph its surface. We cannot directly measure its atmosphere by any normal means. But when it passes in front of a background star, it casts a shadow, and that shadow sweeps across a narrow path on the Earth, perhaps only a few hundred kilometers wide. By predicting exactly when and where that shadow will fall, and then stationing telescopes along its path, astronomers can effectively measure the silhouette of an object billions of miles away by watching how it blocks a star. The timing has to be exquisite, accurate to fractions of a second, and the predictions of where the shadow will land depend on knowing the object's orbit with great precision. When everything aligns, this faint and fleeting event, lasting only a minute or two, can reveal the size and shape of a distant world, and as in this case, the presence of a gossamer-thin atmosphere wrapped around it. It is a way of seeing the all but invisible by watching it briefly hide something bright, and it has become one of our most powerful windows into the otherwise unreachable Kuiper Belt. The detection also fits into a larger and more tantalizing pattern that has been building across all the discoveries we have discussed. Earlier observations with powerful space telescopes had failed to detect obvious frozen volatiles on the surface of this little world, which makes the presence of an atmosphere even stranger, because if the gas is not simply evaporating off surface ice, then it may be coming from deeper down, vented from the interior by some active process. That points back toward the same theme we met on Pluto, the idea that these worlds have warm, active interiors hidden beneath their frozen shells, capable of driving geology and even a kind of cold volcanism. One world after another, the evidence keeps suggesting the same thing. The Kuiper Belt's objects are not frozen all the way through and inert. Many of them appear to have something going on inside, a residual warmth, a slow churning, a capacity to surprise us. And if a 500-kilometer body can manage it, then the question of how widespread this hidden activity might be becomes one of the most exciting open problems in the study of the outer solar system. As one researcher put it, this discovery shows that the Kuiper Belt is not a cold, dead place, but a region teeming with activity and harboring many of the building blocks for complex chemistry. And that single sentence is, in a way, the whole turn of this story. We came out here expecting a frozen graveyard, and we keep finding motion. Pluto convects and may hide an ocean. Charon catches Pluto's breath and turns it to colour. A tiny Plutino exhales an atmosphere, and the strangeness does not stop there. Because scattered through the belt are objects wearing rings they should not have, spinning at speeds that should tear them apart, and at least one body that appears to have come from somewhere it does not belong. The deeper we look, the stranger the inventory becomes, and it is to those final, unsettling oddities that we now turn. Part 10. Rings, Spins, and Worlds Out of Place. Pluto is not the only sizable world in the Kuiper Belt. It was simply the first one we found, and the one we visited. But scattered through the belt are several other worlds large enough to be considered dwarf planets in their own right, and getting to know them tells us a great deal more about what this region is truly made of, and about how thoroughly it can defy our expectations. The discovery that changed everything for Pluto was a world named Eris, found in 2005. Eris is roughly the same size as Pluto, with a diameter of about 2,326 kilometers, and it turned out to be slightly more massive. Its orbit is dramatically stretched, carrying it from about 38 astronomical units at its closest to nearly 98 astronomical units at its farthest, a long, lonely loop through the scattered disk. Eris has a remarkably bright surface, coated in fresh nitrogen and methane frost, and it carries a moon named Dysnomia, roughly 600 kilometers across. It was the discovery of Eris, a world out in the belt that was essentially Pluto's twin, that forced astronomers to confront an uncomfortable question. If Pluto was a planet, then Eris had to be one too, and so did any number of other large objects waiting to be found out there. Rather than expand the list of planets indefinitely, the International Astronomical Union created the new category of dwarf planet in 2006, and Pluto was reclassified. Pluto did not shrink, and it did not move. It simply turned out to have company. And that company revealed that it had never been a lonely misfit at all, but the brightest known member of an immense and crowded family. The reclassification of Pluto is often misunderstood as a demotion, as though Pluto had been diminished, but the opposite is closer to the truth. When Pluto was the 9th planet, it was an anomaly, a tiny, odd, lonely thing that did not fit with the other 8. But the moment we understood it as the brightest and one of the largest members of an immense belt of similar worlds, it suddenly made perfect sense. It was not an oddity at all. It was the first discovered ambassador of an entire population. Pluto did not shrink when it was reclassified. Our picture of the solar system grew, and Pluto went from being an inexplicable misfit to being the herald of the largest family of worlds we know. Then there is Makemake, also discovered in 2005, orbiting at an average distance of about 45.8 astronomical units, with a diameter of roughly 1,430 kilometers and a surface of frozen methane and ethane. And there is Quaoar, a world about 1,110 kilometers across, orbiting at around 43 astronomical units, which holds one of the most baffling features in the entire belt. In 2022, astronomers watching Quaoar pass in front of a star discovered that it has a ring, a band of material orbiting it at a distance of roughly 4,100 kilometers from the object's center. That should not be possible. There is a boundary around every body called the Roche limit, inside of which tidal forces prevent material from clumping into a moon, and outside of which loose material is supposed to gather together into a moon fairly quickly. Quaoar's ring sits well outside its Roche limit, in the zone where, by every rule we understand, the material should have coalesced into a moon long ago. Instead, it persists as a ring, and we genuinely do not know why. It is a small, quiet violation of the physics we thought we understood, orbiting unremarked 4 billion miles away. Quaoar is not even the only ringed oddity. The dwarf planet Haumea is one of the strangest objects in the solar system by any measure. It is large, with a long axis of about 2,320 kilometers, but it is not a sphere. Haumea spins so fast, completing a full rotation in under 4 hours, that its own rotation has stretched it into a dramatically elongated shape, like a flattened rugby ball tumbling end over end through space. That spin is likely the result of an ancient, colossal collision, the same event that gave Haumea 2 moons and produced the only known collisional family in the Kuiper Belt, a group of fragments sharing similar orbits and surface compositions, all of them debris from the same primordial smash. And in 2017, astronomers discovered that Haumea too has a ring, the first ring ever detected around a trans-Neptunian object. A world shaped like an egg, spinning fast enough to nearly fly apart, trailed by shattered siblings and crowned with a ring. That is what is out there. In the region, the diagrams leave blank. Perhaps the most quietly disturbing oddity of all is an object found in 2018, a Kuiper Belt body, whose surface, when analysed, turned out to be abundant in carbon. In materials like the ones we find on certain dark asteroids of the inner solar system, rather than the icy, organic-stained surfaces typical of the outer belt. The most natural explanation is that this object did not form where it now resides. It appears to be a body that formed in the warm inner solar system among the rocky asteroids and was then flung outward all the way to the Kuiper Belt during the great upheaval of planetary migration we discussed earlier. It is a traveller from a warmer past, a piece of the inner solar system exiled to the frozen outer dark, a single misfiled object that records the violence of the migration in its very chemistry. Finding it out there is like finding a tropical seashell frozen into the ice of a polar glacier. It does not belong, and the only way it could have arrived is if something enormous threw it there. And then there is the largest open question of all, the possibility that the Kuiper Belt's strange orbital patterns are being shaped by a world we have not yet found. For years, astronomers have noticed that some of the most distant objects in and beyond the belt, the extreme trans-Neptunian objects, seem to have orbits that are mysteriously clustered, aligned in a way that random chance does not easily explain. One interpretation is that the gravity of an unseen planet, far out in the dark, is gently herding these orbits into alignment. In September of 2025, a survey analysis published in the monthly notices of the Royal Astronomical Society went so far as to propose that an unseen body, at least 25 times more massive than Pluto, might reside within the Kuiper Belt region itself, shaping the orbits we observe. I want to be careful and honest here, because this is exactly the kind of claim the channel treats with respect, but also with skepticism. The existence of such a planet remains entirely unconfirmed. Many astronomers argue that the apparent clustering of orbits could be an illusion, an artifact of the patchy, biased way we have surveyed the sky, finding objects only where we happen to look. The hunt is real, it is serious, and it is being conducted openly, but the planet itself is still hypothetical. What is remarkable is simply that we cannot yet rule it out. The Kuiper Belt may be hiding an entire planet, and we would not yet know. These large worlds also raise, quietly, one of the most provocative possibilities in the entire study of the Kuiper Belt, which is the question of whether any of them might harbour conditions remotely friendly to life. It sounds absurd at first, given everything we have said about the killing cold. But recall Pluto's likely subsurface ocean, kept liquid by internal heat. Several of the larger Kuiper Belt worlds are big enough to retain some internal warmth from radioactive decay, and big enough that a layer of liquid water, perhaps laced with ammonia antifreeze, could in principle survive beneath their frozen shells, in contact with a rocky core. On Earth, life thrives around deep-sea vents in total darkness, drawing energy from chemistry rather than sunlight. The discovery of probable subsurface oceans on moons like Europa and Enceladus, closer to the Sun, has already expanded our sense of where the conditions for life might exist, far beyond the warm, sunlit zone we once thought necessary. Whether any Kuiper Belt object actually crosses that threshold is entirely unknown, and I want to be clear that there is no evidence whatsoever of life anywhere in the belt, none at all. But the mere fact that we can no longer rule it out completely, that a frozen world 4 billion miles from the Sun might in principle hide a dark, warm sea, is itself a measure of how thoroughly the Kuiper Belt has overturned our assumptions about where in the universe interesting things can happen. I should also be honest about how much of this picture is still provisional, because intellectual honesty is the only respectful way to treat a frontier. Many of the most remarkable claims we have discussed, the precise nature of Quasar's ring, the source of the tiny world's atmosphere, the reality of the hidden planet, the full story of how contact binaries form, are at the edge of current knowledge, where new data could shift the picture significantly. Some of these findings rest on a single observation, or a handful, and the outer solar system has a long history of surprising us, of taking what we thought was settled and reopening it. That uncertainty is not a weakness of the science. It is the honest condition of exploring a region we have barely begun to see. We are not reading a finished textbook about the Kuiper Belt. We are watching the textbook being written, line by uncertain line, and many of those lines will be revised before they are final. To stand at a frontier is precisely to accept that you do not yet know what is over the next rise. When you put all of this together, the rings where moons should be, the spin that nearly tears a world apart, the exile from the inner solar system, the possible hidden planet, a single conclusion becomes hard to avoid. The Kuiper Belt is not a simple, finished, well-understood place. It is a frontier in the truest sense, a region where our rules keep breaking and our maps keep coming up short. Every careful look reveals something we did not predict, and these objects do not stay entirely out there, sealed away from us. Some of them, on occasion, come inward, all the way to our skies, carrying a piece of the frozen frontier with them. Those visitors, and the still larger dark that lies beyond even the Kuiper Belt, are where our journey turns for its final stretch. Part 11. Messengers and the larger, dark. For all its remoteness, the Kuiper Belt does not stay entirely separate from us. Every so often, it sends a messenger inward, a small piece of the frozen frontier that falls toward the sun and, for a few weeks or months, blazes across our skies. We call these messengers comets, and the short-period comets, the ones that return on schedules of roughly 20 years or less, come primarily from the Kuiper Belt and the scattered disk just beyond it. When you see a comet, or a photograph of one, with its glowing head and its long luminous tail, you are looking at a fragment of the outer dark, a Kuiper Belt object that has come to visit. The journey of a comet is a slow and violent transformation. It begins as an ordinary icy body out in the belt, indistinguishable from its hundreds of millions of neighbours, dark and cold and still. But the gravity of Neptune is forever nudging the objects near the belt's inner edge, and occasionally one of them is destabilized, sent on a path that brings it closer to the giant planets. Over millions of years, repeated gravitational encounters can draw such an object's orbit steadily inward until its closest approach to the Sun moves into the warmer inner solar system. And then the cold chemistry of the Kuiper Belt begins to run in reverse. As the object nears the Sun, the frozen volatiles that have lain solid for billions of years begin to sublimate, turning directly from ice into gas. Carbon monoxide goes first, then carbon dioxide, then, closer in, water itself. The object grows an enormous glowing cloud of gas and dust around it, a coma, and the pressure of sunlight and the solar wind blow that material outward into the long tails we recognize. An ion tail pointing straight away from the sun, and a curving dust tail tracing the comet's path. We have visited some of these messengers directly. A mission called Deep Impact studied a comet named Tempel 1, and a European mission called Rosetta actually travelled alongside and orbited a comet named 67P, Churyumov-Gerasimenko, watching its frozen surface erupt into activity as it approached the Sunday. There is a thought here that connects all the way back to where we started, to the strange truth that the substances you need to stay alive are, out in the Kuiper Belt, merely building materials. Because those building materials do not always stay out there. Comets, these visitors from the frozen frontier, carry water and organic compounds inward, and there is a long-standing idea that during the early history of the solar system, in the era of heavy bombardment, about 4 billion years ago, comets and other icy bodies may have delivered a significant portion of the water that now fills Earth's oceans. The evidence is debated, and the hydrogen isotope ratios in comets only sometimes match those of Earth's seas, so this is not settled science. But the possibility is profound. The water that was, in the outer dark, just another frozen construction material, may have ridden inward on these messengers and become the oceans you swim in, the rain that falls, the water in your own body. If that is true, then the strangest reversal of all has already happened to you. The frozen building blocks of the Kuiper Belt are not only the ingredients of distant worlds. Some of them may have become the ingredients of you. The cold inventory at the edge of the solar system and the warm chemistry of life on Earth may be, in part, the same material, separated only by distance and by time. But even the Kuiper Belt, enormous as it is not the edge of the Sun's domain. It is only the first of the dark rooms, the nearest and best mapped of them. Beyond the scattered disk, far past where even the dust counter could measure, astronomers believe there lies a still greater reservoir of frozen bodies, a structure called the Oort cloud. Unlike the belt, which is a flattened, disk-like region, the Oort cloud is thought to be an immense spherical shell, completely surrounding the solar system in every direction, an enormous bubble of icy bodies. It was first proposed by the Dutch astronomer Jan Oort in 1950 to explain where the long-period comets come from, the ones that take thousands or even millions of years to complete a single orbit. And its scale defies comprehension. The Oort cloud is thought to begin somewhere around 2,000 astronomical units from the Sun and to extend outward to perhaps 100,000 astronomical units. The Kuiper Belt, that immense region it took our imaginary car 7,000 years to cross, ends at 50 astronomical units. The Oort cloud may reach 2,000 times farther than that. The future of our understanding of all this is about to change dramatically, and it is worth knowing why, because for the first time we are building tools capable of surveying the whole belt rather than catching it in glimpses. A new observatory, built on a mountain in Chile and equipped with the largest digital camera ever constructed, is beginning a project to photograph the entire visible sky over and over again, night after night, for years, watching for anything that moves or changes. This kind of patient, repeated, whole-sky survey is exactly what the Kuiper Belt has always demanded and never received, because its objects are so faint and so numerous that catching them one at a time, as we have done until now, barely scratches the surface of the population. When this great survey hits its stride, it is expected to discover something like 35,000 new Kuiper Belt objects, increasing the number of known bodies out there by nearly a factor of 10. Think about that. Everything we have learned, every world we have named, every pattern we have traced, has been built on a catalogue of a few thousand objects. We are about to multiply that catalogue tenfold in a few short years. The Kuiper Belt we have been describing tonight, strange and surprising as it already is, may turn out to be only a faint sketch of the far richer and stranger region that this flood of new discoveries will reveal. And there is a poignancy to where New Horizons itself now sits in all of this. The spacecraft that opened this story is still out there, still travelling, having long since passed Pluto and Arakoth, now roughly 60-some astronomical units from the Sun, and receding farther every day. Its radio signal, that whisper from a light bulb-sized transmitter, now takes well over 8 hours to reach the Earth, twice as long as it did during the Pluto flyby. It is expected to cross beyond the main Kuiper Belt before the end of this decade, and to keep operating, if all goes well, into the 2040s, sending back measurements from a region no other functioning spacecraft has ever reached. It is, in a real sense, our farthest flung scout, still patiently feeling its way through the dark, still counting dust, still listening, still telling us, in its faint and delayed voice, what the edge of the solar system is actually like. One small machine, no heavier than a piano, carrying the attention of an entire species into a place we are only beginning to understand. We have never seen the Oort cloud directly. No telescope has resolved a single one of its objects in place. It is inferred entirely from the comets it sends us, and it may contain several 100 billion to a few trillion icy bodies, drifting in the profound cold, so far from the Sun that the Sun itself is just one more star among the thousands in their black sky. At those distances, the Sun's gravitational hold on its family of objects extends more than a light year and a half from its centre, reaching out across a meaningful fraction of the distance to the nearest other star, Proxima Centauri, which lies about 4.2 light-years away. The true domain of our Sun, then, is not measured in the orbits of planets, or even in the width of the Kuiper Belt. It is measured in light-years. The solar system is not a small, tidy thing. It is an immense sphere of influence, mostly empty, mostly frozen, mostly dark, reaching out toward the stars. And the planets we know so well are a vanishingly small, bright core buried at its very center. There is a striking difference in shape between the belt and the Oort cloud, and together they redraw the Sun's whole domain. The Kuiper Belt, for all its thickness, still roughly follows the flat plane in which the planets orbit, but the Oort cloud, if it exists as we believe, is not a disk at all. It is a sphere surrounding the Sun in every direction, above and below and all around, which means the true shape of the Sun's family is an immense, mostly empty, mostly frozen bubble, with the flat disk of planets and the Kuiper Belt sitting like a tiny bright coin at its very center. When you look up at the stars on a clear night, you are looking through the inner emptiness of that great bubble, and the comets that occasionally fall toward us are messengers from its frozen outer skin. And so the Kuiper Belt, which began this story as the strange frozen frontier just past Neptune, turns out to be only the threshold. It is the doorway into the outer dark, the first and nearest of the cold rooms, and beyond it the house extends further than we can map, out and out, room after room, into a darkness that thins but does not end until you are most of the way to another star. The belt is where the frontier begins, but it is not where it ends. And, standing at that threshold, looking outward at everything we have learned and everything we still cannot see, we are finally ready to ask what all of it means, and why the truest word for the Kuiper Belt is, after all, the one in the title. Part 12. The terror is structural. We have come a long way from the warm, well-lit room where we began. We have followed a spacecraft across 3 billion miles to a world that should have been dead and was not. We have stood, in imagination, on a fossil from the birth of the solar system. We have walked a surface where the air you breathe lies frozen as stone. We have crossed a belt so enormous and so empty that its nearest neighbours are invisible, and watched a humble dust counter erase the line we drew at its edge, and caught a tiny world breathing out an atmosphere it should not be able to hold. And now, at the end, it is worth asking plainly, why terrifying? What is it, really, that unsettles us about this place? It is not a monster. I promised you that at the beginning, and the promise has held. There is no specific object hurtling toward Earth from the Kuiper Belt, no doom waiting in the dark, no single thing out there designed to frighten you. The comets that come inward are tracked and studied, and serious impacts are rare across the long ages. The hypothetical hidden planet, if it exists at all, is no threat to anyone, simply another world, quietly keeping its distance. The terror of the Kuiper Belt is not the terror of danger. It is something quieter and harder to shake off, and it has been accumulating, fact by fact, through everything we have discussed. The terror is structural. It is the terror of scale, of cold, and of emptiness, and of what those three things together do to your sense of where you live. Consider the cold. Out there, at minus 230 degrees and below, the materials that mean life become construction stone. Water is granite. Air is bedrock. The temperature that would end you in moments is simply the ordinary state of things, unremarkable, eternal. Consider the dark. The sun, that overwhelming presence that lights and warms your entire world, is reduced to a single point of light, a bright star stripped of its authority, casting a glow so faint it would feel like dim twilight at noon. Consider the emptiness. Hundreds of millions of worlds share that region, and yet they are so far apart that from the surface of any one of them you would see none of the others. Only stars, and the diminished sun, and a black sky that goes on without end. And consider that we are still, even now, discovering how far it all reaches, the dust that would not fade, the edge that keeps receding, the greater dark of the Oort cloud beyond. Stand there one last time in your mind. You are on the surface of some nameless Kuiper Belt object, far out in the belt, near the end of everything we have mapped. Beneath you is the dark red crust of frozen, irradiated ice. Above you is a black sky filled with hard, unblinking stars. And there, among them, you find the Sunday not a disk, not a source of warmth you can feel, just a single point of light, brilliant and small, no wider to your eye than a distant street lamp, and around it, invisible to you at this distance, are all the warm and crowded worlds of the inner solar system, the planets, the oceans, the cities, the entire human story, every person who has ever lived, all of it gathered in a tiny bright region around that one small star. From out here, you cannot see any of it. You cannot see the Earth. You cannot see the warmth. You can only see a point of light and the immense, cold, patient dark stretching away from it in every direction, the dark in which you are standing, the dark that makes up almost the entire solar system. And you understand, standing there, that this is the rule, and the warm, bright room you came from is the exception. That is the thought I want to leave you with, because it is the deepest thing the Kuiper Belt has to teach. The solar system you grew up believing in, the one with the planets and the warmth and the light, is not the solar system that actually exists. It is a small, warm, well-lit core, a thin shell of brightness, embedded in something overwhelmingly larger, colder, and darker. The home you live in is not the typical condition of our cosmic neighborhood. It is the rare exception. The typical condition is the Kuiper Belt and the dark beyond it, frozen, empty, indifferent, mostly unmapped, occasionally doing things we cannot explain on worlds no one will ever see. We are not living at the center of a tidy system of planets. We are living in one small firelit room in a house so large that we are still, 3 decades after we first opened the door, discovering how many rooms it has and how far they go. Remember how we began, with the idea that the familiar solar system is a single room, and that beyond its far wall lies an entire wing of dark rooms we never noticed. That was a comforting way to start, because a wing of a house is something you can picture, something with limits. But everything we have learned has stretched that image past its limits. The wing does not end. We sent a probe to find its far wall, and the dust kept coming, and the edge we had drawn, the place where the map said the belt should end, turned out to be no edge at all, but only the place where our knowledge stopped. The rooms keep going. And from the threshold of the Kuiper Belt, looking back, the warm, planet-filled solar system we call home no longer looks like the whole house, or even like the largest room in it. It looks like a single campfire, small and bright and brave, burning in the middle of an endless frozen night. There is a particular kind of vertigo that comes from truly absorbing this, and it is different from fear in the ordinary sense. When you stand at the edge of a cliff, your fear is sharp and useful, a warning about a real and immediate danger. The unease the Kuiper Belt produces is the opposite. It is slow and abstract, and it does not warn you about anything you can act on. It is the feeling of having a stable picture of your place in the universe quietly dismantled, of realizing that the warm, bright solar system was never the main event, but only a small, bright anomaly in an immense, cold dark. Nothing about your daily life changes when you understand this. The sun will still rise, the earth will still be warm, and yet something has shifted. Some sense of scale has been permanently rearranged, and you cannot quite go back to seeing the solar system the way the childhood diagram showed it. That, more than any monster could, is what the word terrifying really points to. Not a threat to your body, but a correction to your sense of where you are. And yet I do not think the right response to this is despair, and I want to say so plainly before we close, because the same facts that produce the vertigo also produce something like wonder. Consider what it means that we know any of this at all. A species of warm, fragile creatures living on one small, bright world has reached out across billions of miles of killing cold and learned the secrets of the frozen frontier. We built a machine and flung it to Pluto and watched a frozen world convect. We caught the shadow of a star bending around a 500-kilometer world and read the breath of its atmosphere. We are building cameras that will multiply our catalogue of the outer dark tenfold. The Kuiper Belt is overwhelmingly cold and dark and empty and indifferent, and we, from our tiny warm room, have learned to see it anyway. The dark does not care that we are here, but we are here, and we are looking, and that act of looking, patient and stubborn and brave, is its own kind of warmth carried out into the night. So that is what the Kuiper Belt is really made of. It is made of the frozen ingredients of life, water and air, and the building blocks of chemistry, locked into hundreds of millions of dark red worlds in a cold so complete that none of it can do what it does on Earth. It is made of fossils from the birth of the solar system, of worlds that convect and crack and breathe in ways we never expected, of rings and spins and exiles that break our rules, and of an emptiness so immense that company and solitude become the same thing. And it is made, above all, of questions we have not answered, an edge we cannot find, a possible planet we cannot see, a frontier 4 billion miles wide, sitting silently just past Neptune, at the threshold of a dark that reaches almost to the stars. It does not threaten us. It simply waits and turns and keeps its secrets exactly as it has since long before there was anyone to wonder about it. And somewhere out there tonight, on a small frozen world with no name, beneath a sun reduced to a star, the slow chemistry of the outer dark is doing something we have not yet learned to see.